Hey everybody, this is Josh and I'm back here to talk to you about SSH and SSH keys and all the fun stuff you can do with SSH. So while we begin, the first thing I wanted to do is quickly talk about what is SSH and what do we mean by that. Well, SSH actually stands for Secure Shell. So Secure Shell, in it you can uh, remote log in to different servers. We use it quite a bit when you're working locally on your local computer, but you want to be able to remote log into maybe a server to update the files, to change some sort of configuration, maybe to even apply the latest patches to a Linux server. And so you need a secure way of doing that, and SSH is one of the most popular common forms of doing that. Before SSH, there was a lot of unsecure methods such as Telnet or RSH or rhost, different ways of being able to kind of log in to it. But if anybody was ever sniffing the network traffic on there, they can see either your password that was on there or other configurations. And so SSH came out in about 1995 as a secure way to be able to exchange information, exchange your credentials, but also when you're actually exchanging any data back and forth, whether it be commands that you're typing in remotely or whether it's files you're transferring, every single one of those bytes are actually encrypted so that if there was somebody sniffing the line and picking up packets that you're transmitting, it actually would have they wouldn't be able to decode that without the proper keys and such. So with that said, I wanted to go a little bit lower and just kind of talk about SSH and how it kind of works. So when you SSH, your client, so your computer over here is talking to some sort of server over here, and on your local computer you would have your private key. Typically it's in your home folder, that's what the tilde stands for, and it's a .ssh folder, and then the private key is usually a file that's like ID_RSA. Now, RSA stands for the RSA algorithm that's used as part of the encryption keys. SSH supports a number of different encryption algorithms that you could potentially use, but RSA is by far the most common and popular ones. So you'll have a private key in there, and inside of it, if you read it, it's just a text file, and it'll say, at the top, private key, and then it'll have a whole bunch of kind of binary encoded ASCII data that's in there. And then you'll also have a public key. Now the public key is something that you can share with other people. Having a public key doesn't really give anybody access to be able to create messages from you without having the private key. So private key you want to keep safe on your computer somewhere. Don't let people have access to that file, but your public key, you're able to copy it to other places. So one of the common things to do is to take your public key and actually to transmit it up onto the server so that the server has your same public key. So what happens is your client then will initiate an SSH connection, and we'll show an example here in just a moment. But it'll initiate it, and then the server is going to send back some sort of random message. You will then use that random message and you'll sign it with your private key. So basically you'll take the message, you'll run it through an algorithm that uses your private key, and out of it will come an encrypted message that you'll send back to the server across. Now again, this all happens just in the SSH program, but it does it for you. It sends that back. And then on the server, the only person that could actually have created that private key and then decrypt it with that same public key you have up there is the person that owns that private key. So their server will use that public key to decrypt it, and he verifies that this is the exact same random message that he sent and he got back by using your public key. And then the server then basically assumes, hey, this message was held by an owner of the private key, therefore I've authenticated him, he is good to go. The client authenticates, and now you're actually connected. Now, one other thing that happens inside this the SSH in general that's not shown here on the diagram is, as part of this kind of comeback message that you're authenticated, the server will actually send a symmetrical key. So when you do this you have a private key and a public key, that's called an asymmetrical encryption, and it's kind of very costly. It actually takes quite a bit of CPU power to encode bytes and do all that kind of stuff. And so it's a lot easier if you actually just had the same password on this side and the same password on the left on the client and on the server, and you can encrypt it. That's a much less costly CPU operation. So what really happens is the server will then exchange a key that from now on all messages going forward are going to use that password essentially to encode the data. And then decoding's easy, encoding's easy, and it's a lot quicker. So just something I wanted to point out there that's not in this diagram. Okay, well, let's go to a terminal. So I'm going to clear out here, and so right now I'm just in your standard Linux terminal, and I am on my local computer, which is Jack Bauer is the name of it. I'm logged in as Josh at Jack Bauer, and I want to, let's say, connect to one of the servers, like a sandbox server that we have here. So if I type ssh dev at ontracksandbox.com and I hit enter, it will go in and it'll actually log into it. It'll give me a little welcome message, and now I'm actually logged in on OnTrack Sandbox and Dev. And all of that happened with that entire diagram in just that few short second or two of the actual connection there. The server now thinks I'm fully logged in. I am logged in as developer and such. And if I wanted to disconnect, I just type exit and I am disconnected and I am back to where I'm at. So let's go over that command real quick. So it's SSH, and then it goes with the user that you want to try to log in as, so dev. You might be able to, might be logging as root or whatever, but in this case it's dev. And we go to the at, so we're logging that user at the IP address or the dynamic host name of the server. So again, in this case, we have it at ontracksandbox.com, and we hit enter. Before I hit enter, I want to show you one thing you can do. You can actually up the verbosity of the connection request with -v for one level of verbosity, but I think SSH command, you can hit V again and V again to get, lots of verbosity. So 3 times the verbosity in this case is how this command works. We hit enter, and here we go. We can actually see a lot of debug stuff that's coming out here. Let's just take a real quick look at it. So SSH is using the OpenSSL software library, that version at that compile time. It reads out of a config file that's in the .ssh folder, and it kind of goes through this. It kind of confirms stuff. Let's see if we can skip around. So here it actually tries to connect to OnTrack Sandbox. It uses port 22, so that's the common SSH port that's used quite a bit. It established a connection. It read out my identity files that are in the .ssh, so the IDRSA, which was my private key that we have here. Here you see it's authenticating as the dev user. One thing that happens is a lot of times to kind of prevent man-in-the-middle attacks where you actually type in ontrack-sandbox.com, but let's say somebody injected into your local network ontracksandbox.com actually points to this bad IP address. They might be able to trick you into actually trying to log into the wrong server. And so SSH has a mechanism of storing off a very specific key that's generated with SSH for that server. So it's kind of like its address on there, a very specific address to it. And so you save it off the very first time you log into the server, into this known host file. And when you log into there again the second time, it'll check that file and it'll see, hey, is this thing the correct thing? And I'll actually walk through an example what that will look like in a second. Again, it checks to see if you've loaded everything and everything else looks good there. But then, like I said, there's a number of key algorithms that you can use for encryption. And so this is just kind of printing out the ones that are available that we have here. Let's see what else we can find. It selects an algorithm. It does a bunch of stuff, blah, blah, blah. And then it's authenticating over a public key. So with SSH, you can authenticate with a public key, public-private key kind of pair, or you can do kind of plain text passwords where you actually type in a password, the password gets transmitted over and returned. That's great and all, but security-wise, you actually have higher security if you actually don't have to type in passwords. One, a lot of people use the same common password, so if your password ever gets leaked from another site, somebody could try to brute force in with that password. The other one is that people in general might have a very easy password to guess, so brute force attacks would possibly go there. And so public-private key is kind of the de facto standard for high security, and actually disabling the ability to log in via password is one of the security measures that we take at Red Sky. Now that does mean that you have to make sure your computer is secure, that nobody's just walking up to your computer and logging into your computer and grabbing your public-private key and stuff. So there is still some onus on there. It's not foolproof for sure. And then we send off a RSA algorithm and it accepts it, and you get a whole bunch of stuff back, and then eventually authentication is forwarding and all that, and then you're logged in. So let's go and do a quick little demo of, if I go into my .sh folder, and let's see what files are in there. So I have my ID RSA, which is my private key, and I'm not going to print it out so you guys can't copy it, but they do have my public key, so let's see what that looks like. IDRSA.pub. Here we go. We have our SSH RSA algorithm, and here's the key, and then this is kind of like a comment at the end of that key, so you can kind of keep track of what's on there or not. So that's the public file. There's also this known host file, so let's see what's in there. So if I cat out the known host file, you see a lot of stuff, and these are all the different unique addresses to different servers that I've logged into. So if we kind of go up here, we might be able to find one for OnTrack Sandbox. Let's see, I've been in quite a bit. Well, let's actually just edit it. So vi known hosts and try to find OnTrack Sandbox. So there we have one version of it if I was logging in via the pages. I think this one might be by IP address. So let's just, we're going to ping OnTrack Sandbox, and we're going to see 22, 23, 239, 197, that. Let's go into our known host file and try to find that, and there we go. So, there it was. So what I'm going to do is OnTrack Sandbox is also known as that IP address. We're going to delete out this key from my file, and that one is now gone. And this is actually really important. If you actually move a server or change the IP address of a server, you're going to get a warning saying, hey, the address doesn't match what the original one was. Do you want to proceed? And you're going to keep on getting that annoying error, or sometimes you actually won't even be able to log in. You have to go into this known host file and actually delete out that entry to be able to log into it. So I'm going to save it out. Now let's try to SSH dev at ontracksandbox.com. And here we go. So it's saying, hey, the authenticity of the host OnTrack Sandbox can't be established. This is the fingerprint, so that's the keyword, fingerprint. This key is not known by any other names. Are you sure you want to continue? And you can say yes, no, or you can actually have passed in the fingerprint of that server you knew was good, and it would have failed right away. So we're going to say yes, and it says, warning, permanently adding OnTrack Sandbox, this ED25519, to the list of known hosts. So now if we log out, we log back in, everything is good there. Okay, so the next thing I want to do is talk a little bit about how do you create an SSH key pair, because by default you're not going to have one generated or anything in there. So I already have a couple, but let's say I didn't. What you do is you type in, with SSH they have a couple other programs, so SSH KeyGen is one of those, and if I hit enter, it says, hey, generating a public private RSA key pair. enter a file in which you want to save. Well, we don't want to overwrite these other ones, so we're gonna just give it a different file name here, ID test there. Enter a passphrase. So now you can use a passphrase so that if you ever go to use this um, public or private pair, you'd have to type in that password first of all before using it. And that's another security method that you could use so that other people who actually steal your file would also have to know a password that you have in your head. So it's a good practice to do it. We're not going to do it here right now, but then you have to type it in again, and it failed here for not having a folder. I'm just gonna see if I can just do this. ID test, pass. There we go. And so there we go. So now we have ID test.pub. Here's a random art that you can kind of see generated from your RSA algorithm there. So let's just go ahead and actually look at this time at the private key. So here you go, begin OpenSSH private key, and here's the key that was just generated there. And so we have it, and we're actually good. And again, we have also the public key that we'd have there, which is on there. So now the question is how do you get this public key up to the server? Well, first of all, you need to have already been able to be logged into it, whether you're logging in as root or you have some other way to get into it, because you have to be able to copy that key up there. So copying files is something that I want to take a quick little side jaunt with. With SSH, there is another tool that comes with it, kind of like the SSH keygen, but it's called SCP for Secure Copy. And what you do is you give it a SCP, and then you give it the local file name, like test.txt, and then you give it the destination you're trying to go to, which would be like dev@ontracksandbox.com. But then you have to specify where on that server you want to put it. So you do a colon at the end of it, and by default, what that will do is it'll put it into the dev user's home folder, which is typically /home/dev is where you put it. But from here, you can either do a relative path from their home, such as like some subfolder 1/subfolder 2, if those folders actually lived up there. Or you can actually do an absolute path by just starting it with / and then you could say home/dev/subfolder 1/subfolder 2. And that will copy that file up into there. Let's actually go ahead and give it a try. So I'm going to copy SCP, that key I just generated, test.pub, like the public key of that, and I'm going to copy it to dev@ontracksandbox.com. And I'm just going to copy it right to the home folder there. I hit enter, and there we go. So we have the public key, the % completed, how long it took, and all that kind of fun stuff. But now let's SSH back into it, dev@ontracksandbox.com. And so if we look at the files, we should have the ID test pub file that actually got copied in there. Now to make this a key that can actually be used onto this server, what we need to do is we need to look at the contents of this file. So like I'll cat that ID test.pub, and what you'd want to do is you'd copy this key, and you'd go into the server, which is the remote servers.sh folder, and there's a file called authorized keys. And in that file is just a listing of these public keys in there, just line by line, just each one of those things. And anybody that has their public keys in there, and it's okay to show this because they're just public keys, not private keys, are in there. So here's mine, and I've got a couple different keys from a couple different computers that are copied in here, and they're pasted in there. So if I wanted to add that test one I just created, I would copy this and insert it into the file anywhere in here. Comments can be started with a hashtag up there, and you can see also that we have this SSH RSA, but there's actually the other algorithms like the ED25519 is an elliptical algorithm, which is really cool and fancy, but basically makes a really secure key with a lot less data. You can see the data that actually is generated in here. So your key sizes are much smaller, but it's just every bit as secure as these long, older RSA algorithms. So very neat. You can see other people that are on here and fun stuff like that. So that's how you get your public key into the authorized key. Notice also that a lot of these files in here are read only by the user. So dev user is the only one that can read these files, which is important. You wouldn't want somebody on the Linux system logging in, going into your SSH folder and changing your key permissions that people can log in as you. So um, all right, the next thing I wanted to talk about is when you're on your local client, how are those keys managed? How did it know to grab the keys from this folder versus that folder and everything? So that is actually all handled by an SSH, they call it SSH agent, that is running in the background. So if I hit enter, it starts a new one, there's a new one kind of running and all that kind of stuff. You can have multiple agents going, but essentially your terminal program here, like this bash, it should by default, or you should set it up in your bash profile in RC files, and there's another video on bash settings there that we can go through, but that's where you should set up your SSH agent launching, and then the thing that actually adds your SSH keys is another program called SSH add, and so here you give it the path to the key you want to add. One thing you can do with SSH add is you can do a -L, and that will list all the keys that are currently added, which right now the only key that's currently in there is my ID RSA. But let's say I wanted to add my ID test that we just created. I'll do an SSH-add ID test and hit enter, and that added that new key in there. And if we do a -L again, there we go. We have 1 and 2 keys now in there. So that's how you add your keys so that they can be used in there. Going back real quick, the method that I was showing you for adding your key to an authorized host, it can actually be done in a different way that is very convenient, and that is with SSH copy ID. And in this case, what you do is you just give it your dev@ontrack-sandbox.com, and you'd hit enter, and it would this would only work if you had passwords enabled. But then you type in the password of that user, and then the SSH key would be copied up to there. If you're obviously you're already doing public key, private key, it already has it up there and it's done. So this is an easy way to copy up your keys without having to copy paste, manually edit the authorized files on there. So the last thing I wanted to talk about is this last file in here called config. Now you can imagine, as you saw with my known host, you might be logging into a few different machines or a lot of different machines based on how much you're doing DevOps type work. And with that, sometimes you just don't want to have to remember SSH, dev or gym or whatever at some sort of random IP address and have to remember all that kind of stuff. You might want to give it a nice, unique name to be able to go into that. Well, the cool thing is that can all be handled with the config file. So if I look at this config file, I'll just do less. And this config file allows us to map host names like ARTech to either fully defined URLs or to IP addresses, so like Logger. And then the cool thing is you can actually specify the user that you're logging into. So for example, Gringotts here has this IP address, but it might be logging in as user Josh H versus this one as dev. And so you can modify this file and add new hosts and new host names and all that kind of fun stuff. So you just have a big massive file of all these in there of different servers that you could be logging into. The other thing you can do is you can put kind of default settings onto all these different hosts that you're logging into. For example, I could type forward agent yes on every single one of these things, but instead of doing that and having all those duplicated lines, I can say for host star, meaning all the different hosts, go ahead and turn the forward agent on, yes, and I'll discuss forward agent in a second, and the identity file. So where is it getting my RSA key to try to log in on there? And so that's what the identity file does there. So now the cool thing is, instead of typing sshdev at ontracksandbox.com, I made a host that says, I'm going to call it OT-SAND. And so I just type in yes, and since I deleted that key, it thinks it's a little bit different. And so that's it. All I have to do is just remember these short little phrases instead of that, and it's less typing, and it's a lot of fun there. The final thing I wanted to show was the forward agent, and that one is really important if you're going to log into an SSH server and then from there do some sort of operation, whether you're going to pull down some Git code that you might be using your local SSH key, or you might be SSHing from that server into another server, and you can do stuff like that. So the forward agent is something that says, hey, forward my keys so that they can be used on that remote host. So again, if I type ssh add -l locally, you see my 2 keys, but if I log into that other server and I do ssh add -l, you see there's my 2 keys on there. If I didn't have that forward agent, it would use the keys of who I logged into on this server, the .sh. It would have used this key instead, and that might not be the key that will get to my personal Git or GitHub repositories and stuff. And so the forward agent is a really important thing to add to your config file. The final thing I wanted to talk about is SSH does have a lot of other cool features. One of the such is tunneling or port forwarding. X forwarding is another thing, and what each one of those things does is it allows you to act as if you were local on that machine running things. I'll give one example real quick. Is we have a client that has a database, and this database can only be accessed locally. The user on the Maria or MySQL database says this user can only be local host to that, which is fine and everything. It prevents people from being able to connect externally and try a whole bunch of brute force attacks on the MySQL password and login. But it becomes kind of a pain if you want to work locally and be able to see the database. So with that said, you can actually do SSH tunneling to make it so that it feels like you're local. And I'll show you what I mean here. I'm going to just try to look at the properties of this database, and I see that the host is 127.0.0.1. Now, if you remember from networking, that is your local host. It's saying, hey, try to connect to a server on my computer, and my username and all that kind of stuff is right here. And I'm port 3307. If you remember, MySQL's standard port is 3306. So in this case, we're saying 3307. And if I try to connect right now, I'll get a failure saying, hey, failed to connect that host port. It's because I don't have that running on my local computer. But what you can do is you can create tunnels through SSH, and I'm just going to show a quick script. I'm not going to actually walk through it, but for this client, we have a tunnel script called tunnel.js that has the credentials in there. It'll create a SSH connection, but if I just run this in Node, I now have a tunnel running from my local host's port 3307 to that server's 3306 on there. And so what we'll do here now is we will now try to refresh this table again, and in a second here it actually pulls down all the data. So that's one way to add security to your databases, is to not allow people to log into them unless they're acting locally, which you can do through SSH, and so now you can use your fancy GUI tools to be able to do that. Well, I hope this was really helpful with understanding all the different things you can do with SSH, and it just has a lot of capabilities. It's really at the heart of being able to do remote server management, and a lot of what we do is full stack developers. So I encourage you to try it out, create your own key pairs. You probably already have if you're writing code with Git, GitLab and GitHub require them, or you can use them in there, and it's a very secure way of being able to do remote server management. So hopefully this was helpful.